Everyone is talking about 3I Atlas, the interstellar visitor. Headlines everywhere. Telescopes pointed at the sky. But there is something else out there right now, something dozens of times larger, and it is directly beneath us at this very moment. This is Bernardinelli Bernstein, a comet measuring 150 kilometers across, the size of a major city. 3I Atlas? Just a few kilometers wide. This giant dwarfs it completely. But here is what nobody is talking about. This object traveled nearly 3 million years to reach us, from a place so dark, so distant, that nothing there has seen sunlight since the planets formed. And right now, in November 2025, it sits in a position we have never observed before. Let me explain. Most comets orbit in the same plane as the planets, the ecliptic plane. They follow predictable paths. We know where they go. Not this one. Bernardinelli Bernstein orbits at 95 degrees to that plane, almost perpendicular. It started above the solar system, swept below, and now it is directly beneath the inner planets, creating geometry we rarely witness. Think about what that means. Every planet, the Sunday all, sitting above this massive object. The gravitational dynamics are completely different. Angles that should not exist. Alignments that break the pattern. But there is something even stranger. This comet became active at 26 astronomical units from the Sunday that is near Neptune, where sunlight is 900 times weaker than on Earth. Most comets stay frozen solid at that distance. They activate much closer, when the sun's heat finally reaches them. Yet Bernardinelli Bernstein started outgassing out there in the cold. Why? The answer reveals something extraordinary. Its surface has never been exposed to solar radiation before, not in billions of years. The materials there are pristine, untouched. Primordial ices that sublimate at incredibly low temperatures. Carbon monoxide, carbon dioxide, ammonia. These substances erupted from the surface far from the Sunday. Scientists captured this using ALMA in Chile. The images showed complex jets shooting into space, evolving, changing, active in ways we have never seen. And then it exploded. Over 100 million kilograms of material, ejected in less than 24 hours. A single outburst. Dust, ice, gas, streaming away from the nucleus. Right now, at this moment, it is losing 1,000 kilograms every second. But here is where it gets truly bizarre. This might be its first visit to the inner solar system. Ever. A dynamically new comet. Something disturbed it 2.8 million years ago, knocked it from its orbit in the Oort Cloud, sent it falling toward the Sunday. What could do that? A passing star. A brown dwarf drifting through the void, or the gravitational tide of the galaxy itself. We do not know. But something out there changed everything for this object, and it has been falling ever since. The discovery itself was accidental. In 2021, 2 astronomers were searching old images, data from the Dark Energy Survey, a project mapping the cosmos to understand expansion. They noticed something odd in the 2014 images, a point of light that barely moved. Most asteroids streak across frames quickly. This one crawled, almost stationary. That meant one thing. It was coming from incredibly far away. They traced it back, found images from 2010, calculated the trajectory, and realized what they had. The largest comet ever detected from the Oort Cloud. At 29 astronomical units, it was already visible. That should be impossible for something so distant, unless it was enormous. Further observations confirmed it. Not 10 kilometers, not 20, over 137 kilometers across. To put that in perspective, Hale-Bopp passed through in 1997, created those stunning tails everyone remembers, visible to the naked eye for months. That comet was 60 kilometers across, already considered massive. Bernardinelli Bernstein is more than twice that size, but Hale-Bopp came close. Inside Earth's orbit, the Sun vaporized huge amounts of material, created those brilliant tails. Bernardinelli Bernstein will not come that close. Its closest approach is 10.95 astronomical units, just beyond Saturn. In January 2031, it will have tails, but you will need a telescope. Its brightness will match Pluto, challenging even for experienced observers. Yet this distance makes the activity even more shocking. Something is driving outgassing far from the Sunday. The volatiles must be extremely reactive. This implies composition, unlike any comet we have studied. Most comets lose their ices after multiple passes. They become dormant, or break apart entirely. This one shows no depletion. Activity is vigorous. Suggesting this could be its first and only approach. Thank you for being with us. Please subscribe, share, and like. Now here is something that will change how you see this object. Recent observations reveal its surface reflects only 4% of light, darker than coal, blacker than asphalt, almost no reflection at all. Why? The surface is covered in organic compounds, carbon-rich materials, tholins created by cosmic rays bombarding it for billions of years. These substances absorb everything. There is also a reddish tint, similar to dark regions on Pluto, but far less reflective. As it approaches the Sun, this will change. The crust will crack. Fresh ice will be exposed underneath. Brightness will increase temporarily. But this comet has a secret weapon. It is massive enough to have significant gravity. When material erupts from the surface, some of it falls back down. Larger dust grains cannot escape. They return. This creates a cycle. Eject, recapture, eject again. Hale-Bopp did this. Despite intense activity, it retained most of its mass. Bernardinelli Bernstein will do the same. Total mass loss will be relatively small. Now look at the orbit itself. The eccentricity is 0.9999, as close to a parabola as you can get while still bound to the Sunday. This means it spends most of its existence incredibly far away. Its aphelion, the farthest point, is between 40,000 and 44,000 astronomical units. That is 0.7 light-years. The nearest star is 4.2 light-years away. This comet travels nearly a fifth of that distance into true interstellar space, where the Sun barely matters. Out there, other forces take over. The Milky Way's gravitational tide, passing stars, brown dwarfs. These can nudge objects on such extreme orbits, change their paths, send them inward or outward forever. This raises a profound question. Is Bernardinelli Bernstein from our solar system, or was it captured from another star? Recent studies suggest many Oort Cloud objects have three origins. First, ejection. Jupiter and Saturn scattered objects early in solar system history. Some went to the Oort Cloud. Second, remnants. Leftover material from the protoplanetary disk never became planets, drifted outward. Third, capture. Our Sun formed in a stellar nursery, surrounded by other young stars. Objects were exchanged, stolen by gravity during close passes. Bernardinelli Bernstein might belong to that third category. An interstellar wanderer, captured billions of years ago, possibly older than our solar system or younger, formed around a different star with different chemistry. We will not know without direct analysis, but the possibility makes this scientifically priceless. In January 2031, it reaches Perihelion. Closest to the Sunday brightness peaks, activity intensifies. Professional telescopes worldwide will observe. Then, the 8th of August, 2033, something remarkable happens. It crosses the ecliptic plane. passes through where all planets orbit. The geometry creates unique alignments, effects on the tail orientation, potentially visible changes in activity. After that, it begins the long journey back. But the orbit will be different this time. Gravitational interactions with Jupiter and Saturn will alter it slightly. The next aphelion is estimated at 50,000 to 60,000 astronomical units. Even farther than before. Orbital period stretches to 4.5 million years. If it returns at all, it will be in the unimaginable future. There is another possibility. A star might pass close to our Sun in the next few million years. Such events happen. They could dislodge Bernardinelli Bernstein completely, send it into true interstellar space, lost forever. This makes the current visit irreplaceable. Scientists recognize this. Proposals exist for a flyby mission, launch within the next few years. Use Earth and Venus for gravitational assists, intercept around 2033 or 2034. The spacecraft could analyze surface composition directly, measure volatiles in real time, capture high-resolution images, sample the coma, answer fundamental questions. One of those questions involves Earth's oceans. Where did our water come from? One hypothesis suggests comets delivered it. Impacts during the late heavy bombardment. But most comets studied have the wrong isotopic signature. Their water does not match Earth's. This has puzzled scientists for decades. Bernardinelli Bernstein could solve it. If its water matches Earth's, it supports the delivery hypothesis. Suggests Oort Cloud objects brought our oceans, not Kuiper Belt comets, not asteroids, objects from the deep outer reaches. This would reshape our understanding of how life's essential ingredient arrived here. There is historical precedent. In 1729, observers recorded an extraordinary comet. 6 separate tails, one of the brightest ever seen. Calculations suggest it was enormous, possibly as large as Bernardinelli Bernstein. That comet never returned. Its orbit was so extreme it likely left the solar system. Bernardinelli Bernstein may follow the same fate. This could be our only chance. The comet also compares to centaurs, icy bodies between Jupiter and Saturn. The largest is Chiron, about 220 kilometers across. Shows cometary activity despite never getting close to the Sunday. But Chiron has been in the inner system for ages. Its composition has changed through repeated exposure. Bernardinelli Bernstein is different, a fresh sample from the darkness, unchanged for eons. As we move through 2026, observations will intensify. Telescopes worldwide will track it, monitor outbursts, measure brightness changes, analyze spectra. Each observation adds clues. Each data point brings insight. This is science happening in real time. While 3I Atlas captures headlines as an interstellar visitor, Bernardinelli Bernstein represents something equally profound. A messenger from our own solar system's edge. A relic from planet formation. A window into conditions billions of years ago. It reminds us how much remains unknown. How many objects orbit in darkness beyond Neptune? The Oort Cloud contains trillions of them. Most will never come close enough to see. But occasionally, one falls inward, gives us a glimpse. Bernardinelli Bernstein is that glimpse. We have 6 years before closest approach. 6 years to prepare, to observe, to launch missions. After that, it fades back into the black, perhaps forever. Scientists call for action now. Missions must be planned immediately. We cannot afford to miss this. The next opportunity might not come for millions of years, or ever. The comet will not wait. It follows orbital mechanics. Time is running out. We have one chance. This is it. Thank you for being with us. Please subscribe, share, and like.